Hello, welcome to this video tutorial on simultaneous equations. So, today I'm going to show you how to solve these equations, but first of all, it is worth having an idea of what simultaneous equations are. Okay, so when we say solve an equation, it's just an equation maybe of this form, 5x plus 7 equals 2, and when we say solve it, what we generally mean is to find out what x is. So this would be just an easy rearranging, bring the 7 to the other side, divide by 5. There you are. That's something that we all know and love. But simultaneous equations is finding x and y that satisfies the equations of two. Simultaneous means at the same time. So let me give you an example because I realise that that's quite difficult to follow. So if we have 5x plus 2y equals 7 and 9x plus 8y equals 5, then this is a simultaneous equation. There are two equations and two variables to solve, x and y. So we can solve it. There are several ways of solving an equation like this. Let me explain how. Okay, but before I do, I just want to show you something. Imagine that we did not have this second equation. Let's just imagine that we didn't. But we have this equation, and let's imagine that the second equation is this. 10x plus 4y equals 14. Then solve this simultaneous equation. We've got two equations and two variables, right? We should be able to solve it. Well, actually, no, we don't. The reason being is that we have two variables, that is correct, x and y, but we only have one equation, 5x plus 2y equals 7. But you might ask, no, we have two equations, the second equation being the 10x plus 4y equals 14. But can you see that is exactly the same as the first equation? All we did to the first equation is times both sides by 2. The 5x becomes 10x, the 2y becomes 4y, and the 7 becomes 14. So actually, because we only have one equation and two variables, we cannot solve it. You see, to solve a simultaneous equation, you must have two variables and two equations. In fact, if we had three equations, we must have three variables. Four variables, we must have five equations. We must have the same number of equations as we do variables. But for this special equation that we're looking to solve, we have two equations and two variables. So that fits what we need. So the first way of solving a simultaneous equation is by graphing the two equations. You see, if we draw it on a graph, what we generally see is that both equations are lines. This is a line because you can rearrange this equation to get y equals 7 minus 5x over 2. You know, that's in the form of y equals mx plus c. The same goes for the second equation. Y equals 5 minus 9x over 8 over 8. Both of these have negative gradients. The first one having minus 5 over 2, second one having minus 9 over 8. So we can graph it. I'm not actually looking too much in detail at what these equations are when I graph it, but it's going to be something like this. So we graph it, say this is equation 1, this is equation 2, and then we find the point where they meet, i.e. the point where they're both satisfied. The reason why this works is because on a line, if this line represents equation 1, every point on this line satisfies equation 1. That's how we draw the line. And every point on equation 2 satisfies equation 2. So, the point where they both meet is the point is a single point that satisfies both equation 1 and equation 2. That's the definition of the solution to a simultaneous equation. So that is one way of solving it. But I'm going to show you another way of solving it using the equation. So let's write those equations again. 5x plus 2y equals 7. And then we had 9x plus 8y equals 5. Okay, so I'm not really going to change the top equation, equation 1. Instead, what I'm going to do is just I'm going to times equation 1 by 4. Both sides by 4. It doesn't really change the equation at all, as long as I do it to both sides. So, let's do it. Equation 1 now becomes 20x plus 8y equals 28. I've multiplied both sides by 4. I can multiply, don't forget, both sides of an equation by whatever I want, as long as what I do to one side I do to the other. It will still satisfy that same equation. In the same way that if I have two twins, Mel and Sue, they look exactly the same, assuming they're identical twins. If I then put a hat on one of them, they won't look exactly the same. But if I put a hat on both of them, they will still look exactly the same. What I do to one twin, I have to do to the other to satisfy that equality of looking the same. The same principle applies here, and all I did was times both sides by 4. Okay, so now I've got two equations. Equation 1 and equation 2 stays the same. You see, the reason why I times it by 4 is because I wanted both to have 8y. I could have found a multiple such that the x's are the same, but I didn't, so the x's are different, 20x and 9x. But I did find a multiple of the first equation such that the y's are the same, 8y and 8y. Now I've done that, I can subtract equation 2 from equation 1, and that will give me 11x, 20x minus 9x is 11x, plus 8y minus 8y is 0, equals 28 minus 5 is 23. What I'm left with is 11x equals 23, which means 11 equals 23 over 11. Now I've got what x is. Let's try and put that x into any of the two equations. So let's put it into the second equation. It doesn't matter which equation, it will give the same answer. You can try it at home. So, first equation is 9 times x, but we know now x is 23 over 11, plus 8y equals 5. So, we can just rearrange. Y equals 5 minus 9 times 23 over 11, divide by 8. Put that in a calculator and you will have the right answer. So now we've got x and y. Brilliant. This method is called elimination because we eliminated the y. Or x, we can do that and it will still be called elimination. There's also a method called substitution, which I will explain ever so quickly. Say we have the same equation, 5x plus 2y equals 7. And we have 9x plus 8y equals 5. Now this method is called substitution. I'm going to substitute equation 1 into 2. In fact, let me substitute equation 2 into 1. It doesn't matter, but I played with equation 1 when I did the method of of elimination. So let's mix it around a bit. So, I'm going to eliminate something. How I do this is I rearrange equation 2 to get a variable on itself. It doesn't matter which variable, I'm going to choose x. So, as you can see, I can rearrange equation 2 to get this. And then, the reason why it's called substitution is that I can stick this value of x into equation 1. Remember, what is equation 1? It is 5 times x, but that's not by x anymore. Let's substitute what x is. 5 minus 8y over 9, all in brackets, plus 2y equals 7. I can then rearrange this. You can do that at home, and you will get y equals a number. In fact, the number you'll get is this, 5 minus 9 times 23 over 11 divided by 8, which you can put in the calculator. And that is basically the method of substitution. Don't forget, once you find out what y is, you then have to put that into any one of the two equations to get what x is. You'll see that x will give you this, just like it did in the method of substitution, of elimination. Sorry, I can't confuse the two, but I seem to do so. But yes, that is the method of elimination and substitution. We are done. I hope you're happy, and you'll tune in for the next video. For now, goodbye.